Now, the velocity in meters per second of a body t seconds after timing commences in the following formula. Find the average velocity during that time. Now, if you're wondering about just what that actually means, alright? So, imagine I throw this into the table function as 3t squared, but in my case 3x squared minus 4. And I do, I don't know, I'll start at 1, end at 3. Alright? Now you can see the times. At the beginning it's actually going negative, which means it's actually going to the left instead of the right. Then after 1 second it's going 8, and after 3 seconds it's going 23. A rough average, but not a precise average, would be to add the 3 of them up. It's going to be 30 divided by 3, which is 10. Is that alright with you guys? If I did every half a second, I'd get a different answer. It depends on how narrow you make the gaps. See the way I'm only taking it every second? In second 1 you're going minus 1. After 2 seconds you're going 8 meters per second. After 3 seconds you're going 23 meters per second. If I made that gap really, really, really small, I'd get a more accurate answer. Does that make sense, Balaam? Alright. Now, so we're thinking an average of 10-ish would be a good answer, okay? So let's find out. Average value is 1 over b minus a, the integral of the function from a to b, bottom to top, of 3t squared minus 4 dt. Alright, integrate that, we're just going to get t cubed, aren't we? And that's going to be minus 4t, and that's going to be, what's b to a in this case? Huh? 1 to 3, is it? 1 and 3, 3 and 1. And that makes this part over here a half, is it? And that's 1 and 3. Okay, a half. Now t cubed is 3 cubed minus 4 times 3, yeah? And actually I'll do it all in one bracket. That's foolish of me. Minus 1 cubed minus 4 times 1. Anybody have it? Save me the hassle. What you get? Who asked me to do it? Alright, what do you get? Yeah. Is that correct? So it's going to be half of 18, which is 9 meters per second, right? Great. Now, let's do the second part of a question nobody did. Alright, so I don't think I need the first part. So we actually predicted 10, didn't we? And we got an answer of 9, which is close to the prediction we actually made, which is pretty cool. It's another way of checking your answer. Now, find the average acceleration. Do I know the acceleration yet? No. Does it say anything like average acceleration during the interval? It means I need an equation for acceleration, don't I? Ah, we have it. Velocity is the first derivative. Acceleration is the second derivative. What's the second derivative of 3t squared minus 4? Just 6t, isn't it? So now, Alex, you're going to do the exact same thing again. 1b minus a, ba, and you're going to integrate 6t dt. And as you said earlier, it's 1 to 3, so 3 to 1. So what we're going to get? We're going to get a half. What happens when you integrate 6t? Turns into t squared, doesn't it? Divided by the 2. Everybody happy with 3t squared? And that's from 3 to 1. And then it's going to be a half of whatever goes on here. 3 times 3 squared minus 3 times 1 squared. A half of 27, take away 3, which is 24. a half of 24 is 12 meters per second squared. We all good? Okay. Now, given the curve, thank you. Now, given the curve whose equation is x to the power of minus a half, find the average value of 1 over y with respect to x in the interval. Alright, so just do 1 over. So 1 divided by y is 1 divided by x to the minus a half. Everybody cool with that? Now, does anybody know what to do with that? Yes? It does become x to the power of a half because it's actually 1 divided by 1 over x to the power of a half. So it's 1 divided by a fraction. And what do you do with the fraction on the bottom? Flip it upside down, and it's going to be 1 times x to the power of a half over 1, which is x to the power of a half. Haven't even integrated yet, have I? Now, who wants me to go over that again? Will I go over that again? Yeah? Alright. So, no, that's alright. Another good lad asking a question, no bother. Alright, so back in the day, x to the minus 3 would be 1 over x3. Alright? And if I had 1 over x to the minus 3, it would be 1 divided by 1 over x3. And then when you divide a fraction, when you divide a number by a fraction, as in 2 divided by a half, you flip the half upside down and multiply. So we're going to bring this up and multiply it instead. And that's why we'd get x3. So if we go back to what I had on the board a second ago, we just did the same here. We turned it into 1 over x to the power of a half and then brought it up and flipped it. Please ask questions, lads, alright? Now, next thing is we now know it's x to the power of a half, and we know we have to integrate it. We know the interval is from 4 to 1, and we know it's 1 over b minus a, which is 1 minus 4, so it's going to be 1/3. Now, Gav, what happens when you integrate x to the power of a half? So add 1 onto it, what you get? 3 over 2, 3 halves, yeah, and then turn that power upside down. So it's going to be 1 divided by 3 over 2, and as we discussed earlier, what happens when you divide 1 by a fraction? And turn it upside down. So what goes here? 2 over 3, exactly. Alright. And I can sort of get rid of that 1 there, can't I? And do it like that. Bit of housekeeping, and in you go. Now, let's ignore the third for a minute and do this. So 2 over 3, 4 to the power of 3 over 2. Is 4 to the power of 3 over 2 8? And then that'll be 16 over 3. And this one is 16 over 3 minus 1 over 3. Oh, sorry, 16 over 3 minus 2 over 3 is 14 over 3. Did anybody get 1/3 of 14 over 3, which is 14 over 9? Yeah. I'll go to 14 over 9. Alright. Now, what's in part 2? The area of the region R bounded by the curve, the x-axis, and the lines x equals 1 and x equals 4. Ouch. Ready for this? Alright. So, I may have to draw myself a little diagram, alright, just to figure out what's going on. So I'm going to go to my trusty table function, and I'll just enter in quickly what's going on here. X to the power of a half. It's just to get an idea of what I'm looking at in my head. Where should I start? Anybody have any ideas where my first x value should be? X-axis. If x equals 0, if y equals 0, it must mean x equals 0 as well, doesn't it? Can you see what happened if you subbed in 0 for y? it also means x would have to be 0 as well. Alright, so I know that's basically telling me the x-axis is also telling me that it's going to be x equals 0, y equals 0, x equals 1, and x equals 4. I'm going to put all those values in, 0, 1, and 4. Alright, and we get a quick look at what's going on. So start at 0, end at 4, step at 1. Now, 0, it says error. What does that mean? Does it ever cross the x-axis? Or sorry, does it ever cross the... it never hits 0, does it? Nope. So let's keep going. Let's have a look at the other points. 1, 1. Fair enough. You can be 1, 1. What's after that? 2 and 0.7. So you can be 2 and 0.7s around here. And then 3 and 0.577. So 3 and roughly 0.6. And then finally 4 and 0.5. Alright. What happens here from 0 to 1? Anybody know there's stuff about exponential graphs? What's going to happen? I'll be able to find that out, won't I? How can I find that out? Do the same thing again. Start at 0, end at 1. Do a step of 0.2 or something. See the really big values here? 0.2 is 2.3. Starting to go upwards, isn't it? And what about in between 0 and 0.2? Let's keep having a look here. Start at 0, end at 0.2. Do a step of 0.01. If you really want to have a good look. They're 10, 7, 5. It's really arcing away, so it's going to go up here and it's going to arc away, but it can never. Yeah, it can never be 0. Can anybody explain why can it never be 0? You can't divide by 0, exactly. So this function here is y equals 1 over x to the power of a half. Is that QE? What happens if x is 0? It's going to be 1 divided by 0. And is 1 divided by 0 allowed? No. Alright, we have a rough idea where our graph is, okay? Now, find the outer region bounded by the curve, the x-axis, and the lines x1 and x4. So, just looking for this area here, aren't we? So this is actually much easier than I'm probably doing there. I probably just did a bit too much. I needed to visualize what I was doing. So what I'm actually doing is this. We're doing the area from 4 to 1. X to the power minus a half dx. And that's your answer, isn't it? So what do we get next? Add 1 onto the power, Connor. Okay. So x power half is correct. Divide it by the new power. And what you do with the half? So 2 over 1, which will just be 2. Alright. And do that from 4 to 1. Alright, it's going to be 2 times 4 to the power of a half minus 2 times 1 to the power of a half. 4 take away 2 is 2. Is everybody cool with that? All good? Alright. Happy days. Right. Alright, let's move on. Any other questions from this exercise?